This is a demonstration of Lenz's law of induction. Basically what he says is that anytime there's a relative motion between a magnetic field and a conductor, an electromotive force is induced by the magnetic field, and that generates an electric current, and the current has its own magnetic field, and the field of the current opposes the electromotive force that produced it. So in this case we're looking at a sheet of copper which is non-magnetic and a strong neodymium magnet, and the magnet will induce a current in the copper, and then we'll see that there are opposing forces that result. So that's an example of Lenz's law in a solid conductor. Now we're going to look at a couple of liquid conductors. This is a bowl of mercury. Mercury is a liquid metal. It's a good conductor. And I'm placing a sheet of glass over the top of the bowl to minimize any air currents that might affect the surface. And now we're going to wave a magnet over it and see what it does. Now, by the way, I'm not touching the table, and the table is sitting on a concrete floor, so I'm not imparting any motion to it other than through the magnetic field. This is a bowl of salt water. Salt water is a conductor, but it's a very poor conductor compared to metals. So we shouldn't expect to see nearly as strong a response to a moving magnetic field over this liquid conductor. That's baby powder on the surface so that you can see a little bit of the movement that does take place. There's a sheet of glass over the top to minimize air currents.